Hello viewers, welcome to my channel Knowledge Unlimited, and in this video we are going to discuss about the initial value theorem and final value theorem. So instead of directly going into the theorems, one should know what is meant by initial value and what is meant by final value. So if for any function, let me draw the function like this. Suppose this is my function, and at t equal to infinity the obtained value, it may be a steady state value, or it may be a finite value or infinite value, or the value which is unknown. The value at t equal to infinity can be called as the final value, because it is the last value that will be reached, that will be obtained for the function. So the value at t equal to infinity can be called as the final value, and the function starting at t equal to 0, so the value at t equal to 0 can be called as the initial value. So with this basic idea, we can start knowing about the definitions of initial value theorem and the final value theorem. So instead of one should know the basic Laplace transforms of these functions, so that they can excel in finding the initial value and final value, which is very important in the gate point of view. So here the Laplace transform of the impulse function is 1, and the Laplace transform of unit step function is 1 by s, and the Laplace transform of t power n is n factorial by s power n plus 1. For example, if you take Laplace transform of t square, then it is 2 factorial by s power 2 plus 1 3, that is 2 by s cube. So in this way you can find the Laplace transforms of any functions which are multiplied with t. So now this is the standard formula, that is the Laplace transform of only cosine wave is s by s plus a if it is cos a omega. So for sine it is a by s plus omega, or if it is a sin omega t, then it is a is constant, it will remain as same, and sin omega t, then you will get omega by s plus omega. So if there is a time shifting, that is e power minus at, then you have to instead of s, you have to write as s plus a, that is here you have to write minus of this coefficient that is present in front of t. So these are the basic formulas that are required to know this. And now let's get started with the initial value theorem. It states that the value, that is initial value, that is x of t at t equal to 0 is called as initial value, which can be written as limit s tends to infinity s into x of s, where x of t and x of s are Laplace transform pairs. This is an important condition, that x of t and x of s should be a Laplace transform pairs. Then x of t equal to 0 is the initial value, which can be obtained directly by limit s tends to infinity s into x of s. So in the converse way, you can write for final value also, that is x of t equal to infinity, which is the final value, can be obtained by substituting limit s tends to 0 s into x of s, where the condition is same for both, that is x of t and x of s should be Laplace transform pairs. So these are the two formulas, that is the initial value. If you want to find the initial value, then do the Laplace transform, and if the given equation is in the s domain, then directly you can apply limit s tends to infinity s into x of s, and for final value you can directly substitute limit s tends to 0 s into x of s. Now to get more clear, let me solve an example for you, that is x of s equal to s plus 4 by s into s plus 2 into s plus 6, that is given x of s equal to s plus 4 by s into s plus 2 into s plus 6. So the final value of this is x of t equal to infinity, that is limit s tends to 0 s into x of s. So if you multiply this with s and s get cancelled, so you can write limit s tends to 0 s plus 4 by s plus 2 into s plus 6. So you can substitute 0 and the value will be 4 by 2 into 6, that is 1 by 3. So this is the final value of the function, that is the Laplace transform of the function is given as s plus 4 by s into s plus 2 into s plus 6. So what happened if the question is given, if the question was given like this, find the final value of s plus 4 by s into s minus 2 into s plus 6, then you should be careful while finding the final value, that is the functions which are stable will have the finite values. So if you recall, I should say this later, but as the time came, I am explained now itself. The system is not stable here, because if you take inverse Laplace transform, you will get an exponential like e power 2t. For example, here you will get a multiple of e power 2t, which indicates that the function as time proceeds will become infinity. So there is no final value. That means the steady state value of this function is 0. And another way you can say that the poles are at s equal to 0 and s equal to plus 2 and s equal to minus 6. So the poles are at s equal to 0 and other pole is at s equal to minus 6 and one is at s equal to 2. So if the poles of the system lies in the right half plane, then the system is unstable. So with this you can say that for the unstable systems, the final value cannot be calculated, whereas you can calculate the initial value. So if you see the previous example, that is s plus 4 by s into s plus 2 into s plus 6, all the poles are lying on the left half of the plane, so you can get the final value because the system given is stable. But now to find the final value and initial value, you have to check not for initial value exactly. To find the final value, first you have to check the stability of the system. That is, if the system has the steady state final value, then only you can get the final value. So that's all for this video, and see you in the next one.